So we just wrapped up the section on probabilities. We are about to get into the section on statistics. And so I have this thing on here that you're probably not going to get tested on. But this is what they sometimes call the normal curve. And so if you hear someone talk about the normal curve, this is kind of what they mean. If you notice it's centered there, it doesn't have like one of these legs coming off here. Sorry, it's horribly drawn, but I meant to draw it straighter, something like that. So it is centered. It looks like sort of like that. Sometimes you might see teachers give grades in this sort of style. They might say the mean is, I don't know, 80, and each standard deviation might be 5. I don't know, 85, and this is what, 90. 95, so I'd have to go up 5 that way. And so this would be 1 standard deviation away, would be, what was that, 75 to 80, I think is what I'm doing. It'd be 75 to 85 would be 1 standard deviation. And so sometimes they'll talk about the 68, 95, 99.7 rule. And so what that means is between 1 standard deviation, we're going to get 68% of the people. So if this was your test, this means that 68 people would be getting between a 75 and an 85, something like that. I think the SAT does scores this way. There's a few placement tests that do this. And then they'll assign letter grades, like maybe this is an A from a 90 to 95 or something, right? And maybe this is a B, and maybe that's a C. So they might do something crazy like that. I'm not sure we're going to talk about that rule. I know we cut out 1 section. The thing that you should kind of know is probably this next picture. And if I'm being honest, I'd probably just put these 4 bubbles here. I'm not sure I'd put the start bubble if I was drawing this. But going through their steps. So this is what, this is how they're kind of generalizing the statistical process, right? So we start out with this population. It could be it's probably a big population, like, I don't know, US population, something like that. And we want to identify our goals. So identify what you want to find out about the population. And I think I mentioned it in the notes, but this isn't like figure out that the population is like this way or that way. You're not doing an actual, you're not actually trying to prove something. You're just trying to figure something out, if that makes sense. So you like US population, what would we want to figure out? Maybe foot size, the average foot size of my population. And so I'm not going to go out there and play Cinderella and measure everybody's foot that exists in the US out there. So what am I going to do? I'm probably going to set up shop in a shoe department or something. And I'm going to pick people. So I pick like what? I don't know, 100 people maybe. 200 feet approximately. And I go and I measure their, I guess this would be the sample statistic. I collect the raw data from them and I measure their average foot size. I use this average foot size that I measured from the 100 people to try to say something about the average foot size of my US population. And then from that, I think I'm what? Identifying goals. We wanted to find out the average foot size of the US population. We choose a representative sample. And here they say this word representative. So we want to get something, we want to draw a smaller number of people, but we still want them to be representative of the larger population. So if you get something that is not representative, that's where bias comes in. And we'll talk about biases in here a little bit. But we hope that when we draw these 100 people, that they represent the foot size of these people over here. We're going to collect raw data. So this is where you go and measure their feet. We're going to make inferences about the population. So we're going to say something about how these 100 feet are going to be like these 327 million, I think is how many people are in the US. So we're going to make some sort of inference about the 327 million. This is where we're making inferences. So if this seems a little weird and like something might go wrong here, you might be correct, right? If we don't choose a representative population, that may not be a good inference that we can make about the whole population. So this is where things can kind of go wrong if we don't choose our sample right. And then we're going to draw conclusions after we know the average foot size of the US population. We can compare the average foot size of the US person to any other person out there. We can compare it to other countries. We can compare it to previous measurements of the US foot size. We can see if people's feet are shrinking, if they're growing. We can see how they compare to other countries, other nations. And so that is the basic sort of steps of the statistical study that they're talking about. We have a big population, but we can't go measure every single one of them. So what are we going to do? We're going to sample them in, come on, next slide. Try to take statistics on the sample. We're going to try to make some sort of inference to make a conclusion about the population overall. Where am I at? Let's skip questions. Okay. Should be slide 3, right? Okay, it is in skip one. How about I skip one? Population and sample size for the following studies. Identify the population, sample, population parameter, and sample statistics. Okay. So we got 4 things we need to answer. What's the population? What's the sample? What is the population parameter? And what's my sample statistic? So the example they give is in order to gauge public opinion on the president's plan to contain Iran's nuclear program, the Pew Research Center surveyed 1,001 Americans by telephone. So what's the population? What's the large group they're trying to get at? That is Americans. What is my sample? I'm going to say all Americans.
The sample would be the 1,001 Americans.
Mm-hmm. Okay. I feel like maybe the sample stats is a smarter thing to answer first. So what's my sample statistic then? Population American opinion. Sample stat is the 1,001 opinions. Yep. So my sample stat is 1,001 American opinions on the president. What did they say? his opinion on Iran's nuclear program, or the president's plan to contain nuclear program. And from those 1001 American opinions, we're going to try to determine something about all of Americans' opinions on the president's, whatever you want to say. Finish that sentence off. The president's plan on Iran's nuclear program. Are there any questions about this one? So there's a bigger group, there's a sample that we're taking from it, there's a measurement that we're getting from the sample, and then we're trying to say something about the overall population. So this is going to come up again and again. They're going to ask us to label the population sample. These are things that will be common in this section. A lot of it's going to be open-ended stuff like this. So if y'all want to type it in, you can type it in. If you want to tell me, you can tell me. I just want to make sure we're all kind of on the same page. I'm not too particular about everyone just like typing in the right thing into quizzes. It's like, it's not my goal. My goal is for you to learn this. Population, so same thing. We want to determine the same thing, different example. Astronomers typically determine the distance to a galaxy, which is a collection of stars, by measuring the distance to just a few stars within it and taking the average of these distance measurements. So what's my population? What's my sample?
The galaxy.
Yeah, the galaxy, right? They're talking about all the stars, basically, here, right? All the billions of stars. And what would be the sample?
The few stars within the galaxy.
Yeah, the stars that you selected to actually measure the distance, right? Few stars selected. And so what is my sample statistic? What am I measuring to these about these stars?
Would it be the average distance from these stars?
Yeah, the distance to the star. And what's the population parameter? What's the thing I'm trying to figure out about the galaxy?
The distance of the galaxy.
Yes, the distance of the galaxy. Exactly. I think the average is the distance to get the distance to the galaxy, but they're still talking about distance. Are there questions about this? About where we're getting this from? Okay. All right. What does it say? So now we're doing the 5 steps that they talk about in the book. You want to determine what percentage of high school seniors regularly use a cell phone while driving. And so this, I think you're supposed to write it like you want to do this study. So how are you going to do the study where you figure out how many high school seniors regularly use a cell phone while driving? So state the goal of your study. What's my population?
High school seniors.
Yeah, high school seniors. I'm talking about all high school seniors. So my population should be high school seniors. Maybe you might want to put the word all in front of there, all high school seniors. The other thing is they say, what do we want to learn? Like, what are we measuring? What are we trying to learn about this?
How many of them use their cell phone while driving?
Yeah, so we're trying to figure out what percentage of them maybe use their cell phone while driving. Choose a representative sample from the population. So how are you going to choose a representative sample from the population? And we haven't talked about like sampling. We get another example in a minute about sampling and biases and stuff. But basically the goal of this is to choose something that's not biased, or to choose something that minimizes bias, I should probably say. So how are you going to do that? If you do a telephone sort of quiz, right? Or if you call people, then you're relying on people that have cell phones or have phones, which is probably about everyone. So it's probably not a big deal anymore. But that could potentially bias your subject towards people that have phones, right? You could do the convenience sampling and ask the people in your class. I guess that's something you could do if you think it's going to be reliable. But if you're like in an honors class or something like that, right, that could contain potential bias. The other thing, you're asking people to self-admit that they do something that's illegal. So you're going to have to figure out a way. If you want an accurate sample, right, if you want them to answer honestly, you're probably going to have to figure out a way for them to take this anonymously, right? So that's something that you'd have to consider when you're choosing a sample. So there are a lot of ways we could choose a sample. We could go look at student ID numbers and do it randomly from student ID numbers. There's a few ways you could do it. There's a few ways you probably shouldn't do it, right? I'm not sure there's any sort of one correct way. Like I said, I think everything is probably going to have its bias in some way. The goal is to kind of minimize that. Collect raw data from the sample and summarize these data by finding sample statistics of interest. So you're going to find some way to pick people. You're probably going to go give them a quiz or something like that, right? A questionnaire. On that questionnaire, maybe you might want to throw multiple questions so they don't know what it's all about. But on the questionnaire, one of those questions is probably going to be, do you use your cell phone while driving? And so collect raw data from the sample. So I don't know how many high school seniors there are. Let's say you have like 300 high school seniors. You don't want to go survey all 300 of them. You're going to survey like a dozen maybe, right? So you're going to take 12 people. You're going to ask them, do you use your cell phone while driving? You're going to get some kind of statistic about those 12 people. You're going to use those 12 people to try to tell me something about all 300 of those people. So collect raw data. So this sounds like where we're giving them the quiz and asking them whether or not they use their cell phone. Step 4 is where we take that number, where we take that number that we got from number 3 and we try to say something about how those 12 people are going to represent those 300 people. And then step 5 is drawing conclusions. So it's like cell phones were like coming. There was a big cell phone boom when I was in high school. So this would definitely you would definitely want to compare it to previous years, but you'd probably also want to know that cell phones didn't exist a whole lot longer for that. I guess in the 90s you had the bricks, right? The Zach Morris style brick. But cell phones were not a thing everyone had. You didn't carry around a cell phone like prior to when I was in high school. it was something that was just coming about. I graduated in '05, I guess, if that gives you context. So you'd probably definitely want to compare it to previous years. You'd probably want to compare it to other places, right? That may or may not be getting cell phones. So drawing conclusions, we're going to compare it to basically other studies out there. Is there a study from a previous year that shows how many people drove and used cell phones? Is there information for other regions? Is there information even for your own region, right? Did someone else conduct the same study? Are you getting the same results as someone else? Part of science is that you can replicate it, right? So if we're doing one study and it's saying something, and then everyone's doing, there's 10 other studies that say the exact opposite, you probably want to scrutinize your study a little bit more and see why yours is saying something different. Are there any questions about this, about how these 5 steps apply to the statistical process that they talk about? This was basically that second page or whatever we went over with that little diagram with the 4 bubbles, 5 bubbles, whatever it was. Okay. So a lot of this stuff, you're gonna have to write some English in this section. You got to write some words, gonna have to write some sentences. There's not like what do I want to say? It's not like x equals 32. This is the one solution for this thing. There are probably multiple things that you can tell me that will get you credit. There's probably multiple things that you can tell me that are incorrect. So I don't know. Make sure you understand, I guess, what's being said, right? Make sure you can kind of tell me in your own words a little bit. Representative sample. So we want to determine the average number of classes skipped by first-year students at a small college during a particular semester. State whether each of the following samples is likely to be representative and explain why or why not. So this is what we're looking for, potential bias. So we get 4 different samples, and they're asking the average number of classes skipped by first-year students is what we want to figure out. So they keep picking all these first-year students. They're picking 100 of them. But the first sample comes from 100 first-year students who belong to a sorority or fraternity. So what can you tell me? I guess this is the key word here, right? That's the key. I'll say quality. That's the key. What?
Would that depend on like what sorority or fraternity you choose for sample 1?
Yeah, but I think what they want to know here is like, how would being in a sorority or fraternity potentially impact whether or not they skip class? So if you're in a sorority or fraternity, would that bias your sample if you're asking them if they skip class? So I'm not sure. I think the book, I want to say the book says.
Would it be because they would get more focused on that, or maybe like they have events with them or something? I don't know.
Yeah, I think the book says that they would probably be more likely to go to class, right? And so part of the reasoning is that like they have that social net of people encouraging them, right? There's a sort of like social net of encouragement. Something along those lines, I think, is what they're getting at here. There's all these people kind of encouraging you to go to class. There's all these people that have been to class, probably that same class you took, and they're probably giving you the test and the homework for it. Probably giving you all those resources for this class, and like they're going to be mad if you don't like take advantage of their resources. So there's a sort of like social net of encouragement that's probably happening here, and you'll probably get a higher turnout with sororities and fraternities. I think that's what the book says. I've never been in a sorority or fraternity myself personally, so I couldn't really tell you. Um, I might say the opposite. Like, you might party too much if you're in a sorority or fraternity. Some of them don't have their priorities right. So something along those lines. How is this going to bias whether or not they go to class? Students who play a varsity sport. There's one thing right off the top. Someone said they might be spending too much time exercising or something and thinking about sports to go to class or something. I want to say the book's the opposite.
Could it also be that they would be encouraged to go more since they're in a sport? And like most sports won't let you in unless you have a certain grade.
Exactly what I was thinking, right? You have scholarships that like completely depend upon that. You have scholarships and you have playing in the sport itself, right, is going to require you to get a certain grade. If no pass, no play, I guess is what they call it, right? You have that factor that's making them probably go to class more. So these are all sorts of things. Like I said, there are probably multiple answers you can give me that would be correct, right? It's not like a x equals 32. There's exactly one solution for this thing. There are lots of sort of things you might be able to talk about, and maybe even something I don't even think about. First 100-year students whom you meet at a student union. I want to say the book says that this one is probably like the best or the least biased. Right, I would say this still has a potential for bias. I would say if you're meeting people at a student union, they're already on campus, right? And so right away, I know if you're like working or something like that, you're probably not sticking around on campus too long afterwards. So student workers, this might fail to grab student workers, right? Fails to grab student workers, maybe. If they're at a student union, they're probably more likely to socialize versus someone that's maybe sitting by themselves and not participating in such a thing. So you might get bias there as well. You're not getting the individuals. The individuals. That's what I was trying to say, right? You're getting the congregating individuals, not the I want to do everything myself sort of individuals. 100 first-year students taking on, this is too easy. If they're taking honors humanities classes, keyword, they're an honor student. Do you think they're going to go to class more or less? I would probably bet more. And so their honors, again, scholarships might come into play here if they're taking scholarships and they're in honors. But also just like that social expectation, right? When you get to honors classes and things of that nature, you're just kind of expected to like, they expect you to give more, right? Are there any questions about these 4 examples? Anything that I said that was crazy or anything that I didn't say that you might be thinking about? Are we done with this problem? I feel like you could write me up something in your notes, or not your notes, in your homework. Something cogent. Something that makes a little bit of sense. Okay. Oh man, now we get sampling methods. So identify the sampling method. So simple random sampling, systematic sampling, convenient sampling, or stratified sampling. Those are our 4 choices. So simple random sampling, I'm gonna go through these like right quick. But simple random sampling is like I get like a random number generator. I get a computer to generate random numbers, something along those lines. I get 6 people. I label each one of them 1 through 6. I roll a die. If I have less than 52 people, I can hold out my deck of cards, make everyone pick a card, and then shuffle the cards and pick them at random, something like that. Like I have some kind of system to randomly choose people. Systematic sampling, this is a simple system. So I do every 5th, every 6th, every 7th person, I'm going to go pick them out. There's like some number and I'm going to pick them out, right? Every so many, I'm going to pick them out. Convenient sampling, this is doing what is easy. So like if I go sample everyone in my classroom, they're immediately around me. It's really easy to sample them. It may not be the best way to sample things, but sometimes it is the only thing we have. So like in the notes, I think we had the anthropology example with them studying skulls. So you're only going to be able to study the skulls that are discovered. You're not going to be able to study the skulls that weren't discovered. You're not going to be able to study the skulls that have decayed, right? There's going to be a very limited number of skulls that you can kind of survey. So maybe convenience is the only way you have to sample. So the last thing is stratified. The thing here to think about here is strata or groups. So when you think about strata or groups, that means we group things into different categories. We put things into different groups. And we sample a certain number from each of those groups. If you get into the humanities, you might hear that word like social stratification. That means like people, they're talking about the different classes, right? Okay, multiple guesses. And it's one of these 4. Like I swear, like if I don't put these solutions in there, whatever, I've done this on the test and quiz. Like people start putting in words that are like I don't know what they're doing. It's like it's one of those 4. What are y'all doing? It's lagging, huh? There we go. I figured y'all were quicker. All right, so let's see if we get this. First class, it was horrible. They bombed the first one, I think, and then the other ones were all right. There you go. That's it. See the green talents. You gonna come help me teach? Okay. Oh, okay. Another example. Every 100th cast iron pipe that comes off an assembly line is tested in its strength. That is that one. Okay. So that is the simple system that I was talking about. That is a systematic. Potato Stevens. Life's not easy being a spud. I'm tell you what. Student ID numbers are randomly selected by a computer. Oh my God, that is giving it away right there with that one word. I feel like. For a survey of students' opinions on college athletics. So that is a simple random sample. And it might be worth noting, like when they talked about the stratified sampling, we grouped them by age. Those were our groups. So within each group, they might be randomly sampling people from those groups. But the key difference, like there could be random sampling within this thing, but the key difference is there are no groups here. There are groups here. So I guess that's why they tack on this word simple in front of there, because we're not grouping things. We're just taking a random sample. So that might be of note. Where is this slide going? Did it disappear? Oh, come on. There we go. Okay. Determine whether each of the following studies is described as observational or experimental. If the study is an experiment, we got to identify control and treatment groups and discuss whether it's single or double blind is necessary. If it's observational, you got to state whether it's retrospective. And so here they say retrospective. And so we went over the notes, but quick recap. A retrospective is a study that sets itself up, like kind of coincidentally, like a experiment. So in retrospective, we have cases and controls. In experiments, we have what? Controls and treatments groups. So these things, they are kind of the same, right? We have a control and we have a control. And we have a, where's my other color? A case and a treatment group that are kind of one and the same. They're getting the variable. These are not getting the variable. So what does this say? It's underlined a bunch of junk. It goes, it's going over my answers. A study at the University of Southern California separated 108 volunteers into groups based on psychological tests. This is not something that exists. So I think this happens only in imagination land or something. But we have 108 volunteers. We're going to separate them into groups. They're going to give them psychological tests to determine whether they're lying and cheating. And they determined who lied and cheat, and they determined from who lied and cheat, they discovered that they have different brain structures from the people who did not lie. So is this an experiment or is this a observational study? So again, an experiment, I don't know if I said it, but like an experiment is something where you're actually doing, you're proactively giving someone a treatment and you're proactively like making a control, or yeah. An observation is where you just look at what people are doing, or a study, an observational study. So this thing should be, how did we all get it? Observational. We are not telling them to go lie. If we were telling them to go lie, then it might be an experiment. And so then the next question is this retrospective or not retrospective? So do we have a variable in control? Did it set itself up so that there's a variable in control that determine another factor?
Wait, could you repeat that? I really didn't get it. I didn't hear
So
it.
a retrospective study is a study that sets itself up like an experiment. Like by coincidence, we have people that do the thing and we have people that don't do the thing. And we're drawing some sort of conclusion about if they do the thing, then they're more likely to have this. If they don't do the thing, then they're more likely to be like this. So this is a retrospective study. There's another one that comes up in a minute, and it sounds like it should be retrospective, maybe, but it's not, and I'll tell you why when we get there. This one is, if they lie, they're more likely to have this brain structure. If they don't lie, then they're more likely to have like a different brain structure. So whether or not they lie is telling me their brain structure. So I think the next thing we want to do is case and control groups. Okay. Case versus control. So what group would be the case group? What group would be the control group in this situation?
The liars.
Yeah, these are your liars, right? Liars and cheaters. These are the people that don't lie. Truth tellers. What do you even call them? So we have our variable, the people that have the variable, which is lying and cheating, and we have people that don't have the variable or some sort of control. Is that right? Okay. I got distracted by my barking dogs. Okay, so that's it. Case and control. Is this no? That's not an experiment. Okay. Yeah, that was the one thing we're answering here. Are there any questions about this? I think this is the last thing we're answering on this. So being able to determine whether or not something is a experiment or study, and then if it is a study, is a retrospective study. And they kind of give you the definition for retrospective study. You should be able to get a case and a control. Oh, the magnet example. I'm sorry about that picture. I don't know where it came from. Type of study. Determine whether each of the following studies describes is the same instructions. Here's the example. A study of the effects of magnets on back pain. Some subjects were treated with magnets, while others were given non-magnetic devices with a similar appearance. I think we call those placebos. Journal of the American Medical Association is where it's coming from. The magnets did not work, apparently. Oh, y'all are too wound up this morning. Oh, hush. If he's scaring you, he'll be out of there by the next slide. If you get the meme reference, then you get the meme reference. If not, I guess you have to go Google miracles and go listen to that song or something. I don't know. He has no idea how magnets work. And a study of the effects of magnets. So we said it was an experiment. We are giving them magnets and we are giving them this other thing called a placebo. What is the control and treatment group? Hush. And then we'll talk about single or double blind.
Would the control group be the one that does that? The ones that get the fake magnets?
Yeah, they receive the placebo or fake magnet. And the treatment would be the people that got the real deal, right? And why would we do that? Why do we give them like a control or placebo? I talked a little bit about this, but there's something called the placebo effect, right? And so if you tell people something's going to work, the power of the mind is going to make them work a little bit. Is it going to make it work as much as a valid treatment or something that actually does work? No, but it would. You have to like prove that your treatment is actually better than just someone believing it's going to work, right? So single blind or double blind? Are we doing the single blind? So what does single blind mean? The person taking the treatment, right, or the placebo doesn't know whether or not they're taking the treatment or placebo. Would you want to keep that a secret from the person taking the treatment?
Yes.
Yeah, absolutely. Like if you don't do that, then you're not going to get around the placebo effect, right? So we have to do single blind. What about double blind? Do we need to do double blind here?
You don't need to, but wouldn't it be better that way? Like it has less chance of the person giving it away.
Yeah, I think the book is probably going to say it's not necessary, but like it is probably better. If you can do double blind, it's probably always better to do double blind, in my opinion. I don't know if the book's gonna say the same thing, but like you don't want the person giving them maybe the magnet or giving them the placebo to know it, because when they give it to them, maybe they're like, here's your treatment, right, with the big smile, or maybe they're like, here's a treatment. Like those sorts of little things can really have big impacts on how people answer questions. So you might want to double blind it. And how would you do that? The person giving them the magnet doesn't know whether it's a magnet or not. You'd have to code them somehow, right? Put a number on there. It is possible, right? It definitely requires more work. Here, it's probably not necessary because people probably aren't going to fake back pain. But back pain is one of those things, and pain in general, right? It's like on the scale of 1 to 10, are you a frowny face or are you a happy face? We don't actually have a really solid measurement on back pain. So it might be beneficial here. If I were to guess, the book's probably going to say not necessary. I think the example the book gives is I think they say something about ADD medication or something, and then they ask this person whether or not the person is hyperactive, and it's like that's such a, what do I say, subjective sort of term, right? It could be a lot of things. And whether or not they know if these people took the medicine might influence whether or not this person says they're hyperactive. But if you're giving these people a quiz, right, and it says on 1 to 10, tell me what your back pain is, double blinding is probably not necessary then, if you can find a way kind of around it, which here I think you might be able to do. But as you said, I really do feel like double blind is kind of the superior way to go if you're worried about this experimenter giving away some information. Definitely single blind, double blind, it's probably better, but it's probably not necessary to do it per se on this one. Okay. I think the more important thing is that you know what those things mean. If it's single blind, the person taking the medicine doesn't know whether they're taking the medicine or the placebo. If it's double blind, the person taking the medicine doesn't know, and the person giving them the medicine directly to them doesn't know. It puts more degrees of separation in there, at least, when you do double blind. Okay. So 39, I think these are the same instructions. A study by Brown University social scientists found that 18.6% of first-year women students surveyed at an upstate New York college experienced sexual assault during that first year. So maybe kind of a horrible example, but I think maybe to bring home the point and difference of what an experiment is versus study. So are they proactively doing this, or are they sitting back and observing this sort of thing happen? Oh, it's lagging again. And I hope all of you answered correctly on this one. I hope you're not doing this as an experiment. That's pretty horrible. Yeah, we're definitely observing this. We're definitely not proactively going and assaulting people. And so if it's an experiment, I think we got to do, oh, no, it's not an experiment. Sorry, if it's a study, we got to know whether or not it's retrospective or not retrospective. So I would say this, it seems like maybe you could get a case and control out of this, like people that had assault versus people that don't have assault. But what sort of deduction or conclusion are you making out of that? Are you deducing that people that have this assault are more likely to do X, Y, Z or whatever versus people that don't have it? And I think that's where this starts falling apart as a retrospective. So I guess I kind of hinted at what it was. But so it kind of seems like maybe there's a case in control, but they're not actually making any deduction about that sort of thing. So in the previous one, when we talked about people who lied and cheated, we were making a deduction about like their brain structure, right? We're saying, well, these two factors, whether or not they have the factor or whether they do have the factor, right, is going to determine this other thing. Here, we're not doing that. We're just kind of observing these people got assaulted and these people didn't. They're not making any sort of deduction off of that sort of thing or showing that these lead to anything else. So I think that's why they say that one's not retrospective. Okay. So I think they want to know how you're going to do this. So what type of study and what type of statistical study is most likely to lead to an answer to the following questions. So if the study is an experiment, we got to identify the same thing. So we still want to identify pretty much the same thing. But now instead of looking at a study that's been done, we want to talk about doing a study. So does taking a daily multivitamin reduce the incidence of strokes? So are we going to do this with an observation or an experiment? I think it's the first question. Starting to mow. So is this an observation or an experiment?
Experiment.
Yeah, you can just, you probably want to do this with an experiment. You're not just going to go around and ask people, did you take vitamins every day? You can go and give someone a vitamin. It's not going to like experiment. Sorry. It's not going to raise any sort of ethical quandaries, right? Go take this multivitamin. It's fairly low risk thing to do. And so if it's an experiment, we have what, a control? Is it control and case? What are the words they use? Control and treatment. Sorry. Who's our control? Who's our treatment? How are we going to do that? These will be the people taking multivitamins. Multivitamin. Okay. So we're going to get people to take multivitamins. What are we going to do for a control group? Are you going to give them nothing to take? How would you do that?
Give them something else that's not the vitamin. I don't know.
Give them something else that's what?
Something else that's not the vitamin.
Something else that's not the vitamin. So something that has inert ingredients, like a sugar pill is what they call it, I guess, or a placebo, right? You're going to give them some sort of placebo. Something that looks like the real deal, but is not. So it looks like a multivitamin, but it's not. And then I guess the other question is what, single blind, double blind. So are we going to do single blind?
You could for this experiment.
Do what?
You could.
So if we're going to give people a placebo, should we do single blind?
Yes.
Yeah. So if you're giving people a placebo, you shouldn't tell them that they're taking a placebo, right? You should tell them, hey, here's the real deal. So single blind, definitely want to do this, right? Double blind. Do we need to do double blind in this one?
You don't need to, but it would help with the results.
Here I think you're pretty safe not doing double blind. And like part of the reason I say that is because we're studying strokes, right? And so if someone has a stroke, they're going to have a stroke. If they don't have a stroke, they're not going to have a stroke. I don't think there's any way that your experimenter and the way that they phrase things is going to make people have more strokes or less strokes, right? If that makes sense. Like a stroke is a pretty definitive thing. So I think here it's really not necessary. Okay. And part of the reason why I say that, like I said, is because you know whether or not someone had a stroke. I don't think they're going to lie about having a stroke. I don't think anything that this person tells them is going to make them have a stroke or have any less strokes. I think would be pretty safe just doing single blind. But anytime you do a placebo, right, you definitely want to do single blind. You don't want to tell this person that they're taking a placebo. That's going to undermine the whole thing of figuring out whether or not this was a placebo effect or not. Are there any questions about this one? Anything I said that was too crazy? Anything you might want me to go over? Okay. I think that's pretty good. We're at 47, and I think getting close. Margin of error. The following summaries of statistical studies give a sample statistic and a margin of error. Find the confidence interval and answer any additional questions. So a poll is conducted the day before an election for state senator. There are two candidates running. The poll shows that 53% of the voters surveyed favor the Republican candidate with a margin of error of 2.5 percentage points. Should the Republican be confident that she'll have a victory party? Why or why not? So they want us to find the margin of error. So what is my margin of error for this thing? How do I figure it out?
Isn't it like the number it gives you and then minus the margin of error?
So 53 minus 2.5, I think is what I'm doing.
And then you also want to add it?
Yeah, and add it. We want to subtract it and we want to add it. So this kind of goes back to that same like first page. They call it margin of error here. It's pretty similar to what our standard deviation and mean does, right? We're going to add and subtract it. So I think we're going from 50.5%, I guess what we're talking about, and we're going up to 55.5%. If we subtract and add that to 53. Should the Republican be confident that she'll have a victory party? Why not? So I'm assuming it probably takes a majority to win. I mean, well, if you have majority, you do have plurality too, right?
Would it be yes because there's a more likely chance for her to win or something?
Yeah, she should be pretty confident, right? This is our confidence interval. So the way they do things here is okay. They're trying to introduce like confidence intervals and they're trying not to make things too complicated. But usually when you talk about a confidence interval, they give you a percentage. And usually the default sort of thing is to talk about a 95% confidence interval. And so the way that we would maybe say it is that we're 95% confidence that she'll score somewhere between 50.5 and 55.5. And there's a certain like trait I'm trying to get at here. If I want to do like maybe a 68% confidence interval versus, I don't know, 98. So if I want to be, let me think about this. If I want to be less confident, that means I would get like a smaller interval. So maybe I'm going like, I don't know, 52.5 to 53.5. But if I want to be more confident that I'm going to grab it, I'm going to have to get a larger interval. So let me go maybe 10 both sides, go what, 43 to 63 or something. So there's a certain trade-off that we get depending how confident we want to be. If we want to be really confident, we're going to get a really, really large array of numbers. If we want to be not so confident, we're going to get like a smaller interval here. So this is one of those judgment questions. Like, what are you doing these statistics for? Are you doing them for like heart surgery, or are we like throwing hand grenades here, right? You know, it's like, how accurate do I need to be for this sort of thing? But the more accurate I get at predicting something, the less accurate these numbers will be, right? Because it's going to be a larger range. So this goes back maybe to that first picture I had with that normal curve. These are the kinds of questions we're asking ourselves when we do statistics. Like, how accurate do I need to be? They don't tell us what the confidence interval here is. They just give us the word confidence interval. But typically when you see it, they will give you a percentage along with the confidence interval. So if this was 95%, I would say I'm 95% confident that we're either going to score between a 50.5 and a 55.5. So it's still possible she could lose, but we're confident she probably won't. You know, even the weird things happen, right? It's kind of the moral of the story. I didn't answer everything here, right? So should the Republican candidate show up a victory party? Yeah, okay. And the reason why is because this is over 50%, right? And as long as she's scoring over 50%, we expect that she's probably going to win. Okay. Now we're going to look at studies, and I think we'll get two more examples here. 53 and 54, I think, is the last problem, but we're going to get two studies to look at, and they're going to get broken apart kind of the same way. We want to identify population and population parameter. So a Fox News poll of 900 registered voters found that 19% of Americans regift, gives gifts that they received, and women are more likely than men with 21 to 16, and the results are nearly independent of income. Margin of error was 3 percentage points. So what's my population? What's my population parameter?
Would population be the amount of Americans that regift?
Not just the regifters. We're trying to figure out who regifts out of all Americans, right? The population parameter, I think, is the thing that you're saying. This would be the percentage that regift out of the population, which is all Americans. Questions about that? And if that's my population, I think my sample is almost, yeah, that's it. my sample would be what? I think it's the next slide. So what's my sample then? I'm not going to look at all Americans. I'm looking at
The 900.
the 900 registered voters that took our poll. And then if that's the 900 registered voters, not pop. Now I'm in sample, and this is sample stat. And this would be out of the 900, right? So for sample, I'm talking about the 900 people. And for the sample stat, I'm talking about the same number I was talking about with my population parameter, but only for the 900 people. And then they use some stratification, right? They stratified it by gender, divided it into male and female. That was that question. I didn't even look at the question, did I? It did say, yeah, sample and sample stat. Okay. C is this the identify, or is that part D? Identify the type of study. Is this experimental or observational?
Would it be observational?
I think it's observational. And then if it's observational, is it, what is that word they use? Now the word's escaping me. Retrospective.
Yes, it is.
You said what? Yes?
Mm-hmm.
I would say that maybe they're dividing it into men and women. Are they saying that women are more likely to regift than men because they are women? If they are, then I think it's retrospective. If they're not, then I think it's not retrospective. So it really depends what they're trying to say, and it's not really clear what they're saying, right? They're just giving you these numbers. So I think I said no because I don't think they're actually like coming out and saying, I think they're suggesting it, but I don't think they're actually coming out and saying that these people being women is what makes them more likely to regift. If they were saying that, then I think it would be retrospective, but I don't think they are. I could be wrong. I don't know. So it's definitely a study. Whether it's not retrospective or not, it's a little bit on the gray side, I think, depending how they're saying things. Okay. And the last thing is identify the type of study. Next thing is identify any more information you might want to know. It's something along those lines. What does it say? Discuss what additional facts you would like to know before you believe the study or acted on the results of the study. So the thing that we should probably figure out is this margin of error. That is the thing that kind of jumps out to me personally. There are other things you could also discuss. So if we want to talk about women, if we're at 21% for women and the margin of error is 3%, what are the possibilities for my women? What's the lowest their percent could be with confidence?
Would it be 18 to 24%?
Yeah, 18% to 24. And I know I said this in the notes somewhere, but like one of the things that statistics is really good at is it's a really good kind of bullshit detector, right? And so men, we're going to take 16%. I think we're going, what, 13% to 19%? We're taking 16, we're adding and subtracting 3 to get this interval. And so what is this telling me? Are women regifting more than men? Can I draw that conclusion from these numbers that women regift more than men?
Yes.
Hmm? So is it possible that women regift only at 18%? Is that a possibility?
Yes.
Yeah, it's within our interval. So women could be regifting at 18%. Men could be regifting at what? 19%. So can we say that from these intervals and our margin of error being 3%? Can we say that women are regifting more than men? That is not a conclusion we can draw from this study. It is not supported by this study. So this is something that we do quite a bit in statistics. It's like, well, these range from this number and these range from these numbers. And we try to compare populations that aren't the same. It is difficult to do. So to discuss what additional facts you would like to know before you believe the study or acted on the results. So another thing is the other thing is like sample bias. Everything we talked about, sample bias. Those are other things you could bring up at this point, right? How are they determining these people? How are they picking these people that they're sampling? Are these Fox News viewers? Because they might have different ways of doing things than people that aren't Fox News viewers, you know? They might actually believe Fox News, who knows? Yeah, so all these things, there are a lot of things you could tell me. This is the one thing that kind of jumps out to me, is that they have a 3% margin of error. Your women could be lower than your men. And so that doesn't conclude that women are actually regifting more than men, like they're trying to suggest. Are there any other questions? Do y'all have any ideas of things that you might want to know? Okay. Trying to think of what the other class said, if they brought up anything I could think of. I think they mostly talked about sampling and the margin of error. Are they calling people on the phone? That's another thing. Someone calls me on the phone, I'm just going to be like, not interested. I'm too busy right now. Give them that old good line. Identify the population parameter. All right, so last problem. We want to identify pop and pop parameter. My population here and my population parameter. Okay, the phenomenon of stereotype threat occurs when people, often women or minorities, are reminded before taking a test that the test will be used to evaluate intellectual or academic abilities. Studies show that test performance declines significantly when such reminders are given compared to when they are not given. So I don't know if you ever ran across it, but usually within one of your classes, within one of your humanities classes, they'll usually talk about the brown eyes, blue eyes experiment. That's kind of what this reminds me of a little bit. We can see that stereotype threat like comes into play in that experiment. It was an experiment done by Jane Elliott is the lady's name, and she lived in a place that was pretty socially like pretty stagnant, like racially, right? It was all pretty much just white people, and she was trying to devise a way to explain like racism and prejudices to a relatively stagnant population. So she did this whole thing where she discriminated against people based on their sort of eye color. One day, I think it was the brown eyes were the superior, and then the next day she turned it around and flipped it on them and like told them blue eyes. But the people actually started performing better or worse depending which category they were in. So it is an interesting experiment to look at. they'll probably cover it in one of your humanities classes if you hadn't covered it already. But a little bit of a tangent, but we want to identify what population and population parameter. So what is my population here? So what's the big group that they're talking about here?
People who are stereotyped.
People who are stereotyped. So they're talking about women and minorities, basically, right? The population parameter would be what? I think it would be what? The test performance, right? Test performance, and we're going to do test performance with and without, priming them, or giving them that sentence that says, oh, you're going to be compared now. So we're going to compare their test performances, the variable being the sort of priming that we're doing. So this very much sounds like an experiment. Okay. And we're not going to go out there. And I'm not sure. They're not really straightforward here, if I'm being honest, right? When I say all women and minorities, I'm assuming they're probably doing this just within the U.S. So I should probably say that, something along those lines. Different countries are going to have different structures of what a minority or what race is, even, right? So I'd probably assume that this is in the U.S. So you're not going to go out there and go in the U.S. and go to every single woman and every single minority that exists out there and say, hey, I need you to come take this test. So we need a sample. So this is where we get the ones that were selected. So I know we're kind of going over, hopefully we're not beating a dead horse too much. But now we're taking a sample from the larger population. So the sample is going to be the people that we selected. The sample statistic will be what? How these people performed on the test. So how the people selected performed on the test. With priming and without priming. Are there any questions about this population sample? And what we're recording, I guess, is their test performance. Phenomena. So what are we doing? Identify the type of study. So we talked about, well, I kind of said it already, but is this an experiment or an observational study? So I think we're going to tell them proactively, right? We're going to go in there, we're going to tell them we're going to either prime or not, right? So we have a variable and we have a control. And by priming, what I mean is you're telling them, hey, this is going to be part of how we judge you or something, right? Is what they're telling them. And so we have a control and we have a variable group, or what is the words they use? control. Treatment is the word they use, right? For the variable. So we have to identify our control. We have to identify our treatment. So if we're doing priming, treatment would be the people that you tell it to, right? And the control would be people without. You're going to have some people that you tell it to. You're going to have people that you don't tell it to. Are there any questions about this? Are we getting these? I hope I'm not just like speaking and just like talking to myself here. Come on, doggy. You getting anxious? My dog's getting anxious. So I don't know. All right. So I think we got one more slide maybe. Part D is like, what do I want to know more about this study? So what are some potential things that you would like to know about this study before you determine its validity? So what are more things that we might need to get on the study? Is there anything y'all can think of? That's what I want to know. I can give y'all a few things.
Maybe compare it to the non-minority individuals.
To the what minority?
Non-minority.
Oh yeah. So for the majority, yeah. So you want to compare it to whether or not this minority status actually has anything to do with it, right? Or is it just something that just happens to everyone? So you definitely want to make sure that like you are showing like this minority status is an actual is creating an extra barrier, right? And so yeah, that's a good thing to compare it to. I was thinking about comparing it even to like other countries, right? If we're gonna do it within the US, and I kind of hinted at it, but like other countries do not have the same race categories that the US has. And usually like you go into it when you get into humanities, but they'll talk about how race is a social construct and it is not the same across different countries. That and I heard an NPR article not too long ago. It's been maybe a year, but they were definitely talking about like America has definitely like a sort of unique sort of relationship with its race, because previous to America, a lot of the sort of racism and prejudice that existed was more like, what do they call it, like tribalism. It was more between different groups of people, different factions. But when we get America, we get this sort of melting pot idea coming in, and we have people of every different race, creed, color that come and live here, and we have a lot more sort of internalized racism that exists here and within the US. And one of the things that they talk about in there is also like a lot of those eugenicists from the Jim Crow era and all these sorts of things. They were a big influence on like Nazi Germany as well. So that's something that I think about quite a bit. But yeah, it's just, I don't know. Sometimes I just feel like it's weird that like Nazi Germany gets like, and they did, like they deserve the flag, right? But like I feel like it's weird that they get like it's kind of presented as the pinnacle of racism when their influences were like U.S. eugenicists, and I don't know, man. Like our education system has been infiltrated by people that like have pushed these like false narratives of like what's happened in our country. So it is something that like I think about quite a bit. Probably don't want to go on too big of a tangent, but if y'all want to talk about that, I can. But this is the last question, and I don't want to. I could probably rant for a couple hours on that, but something you definitely want to do is compare this study to things that are happening in other countries, right? It was what I was trying to take away before I got on too big of a tangent. Yeah. Any questions over this? Any ideas that you could maybe think? You had some good ideas.
How they selected the people?
Yeah, bias in selection, right? If we're gonna pick out women and minorities, are you doing them from social securities? Because then you have people that are undocumented that you're not going to capture, right? Any other questions, quandaries, complaints, concerns, anything out there? I think this is the last question that we have for today. That's all I have for you today. And if that's it, then I reckon that's it. Stop share, stop recording.